Hello students. So today we are going to discuss about the mode of operation. This session came under the CO2. So the aim of the session is basic concept of various modes of operation in block cipher, demonstrate block cipher mode of operation, describe block cipher mode of operation, list out the blocks, describe the mode of operations. At the end of the session, students are expected to know, define what is the block cipher, and they may summarize about the block cipher mode of operations. So in this module we will discuss basic concept of different modes of operation in cryptography. This module cover in-depth analysis of working principle of this mode of operation with their computational complexity. This session provide an overview of modes of operation. Much of the theory of public key crypto system is based on the number theory. This session is designed to provide a comprehensive understanding of different modes of operation used in block cipher. Block cipher are widely used in cryptography algorithms that encrypt fixed size of blocks. The proper selection and understanding of block cipher node of operation are essential for secure and efficient encryption data. Modes of operation are method used to transform a block cipher into a stream cipher or hashing algorithm. This mode allows a block cipher to process larger amount of data than the block size of the cipher. By dividing the data into blocks and applying the block cipher to each block in turn. Some commonly used mode of operation includes electronic code book, that is also called the ECB, cipher block chaining, that is called CBC, counter CTR, and counter mode, that is GCM. One by one we will discuss one by one. So first of all, block cipher mode of operation, electronic code book, ECB. In the electronic code book, the plain text is divided into fixed size of blocks such as block 1, block 2, block 3, and so on. Each block is encrypted independently using the encryption algorithm E with the same key K, producing the corresponding cipher blocks. This encryption process is repeated for each block of the plain text, resulting in a series of cipher text blocks. During decryption, now that is the part of the encryption. Now during the decryption, each cipher text block is decrypted independently using the decryption algorithm D with the same key K. Yield the corresponding plain text block is not K. The decryption process is performed for each cipher text block, allowing for the reconstructing of the original plain text block. So it is the block diagram for the block cipher mode of operation. See, they are the plain text P1, P2, P3 up to the Pn. Say they are the number of the n block. N are the number of the block which to be encrypt. So there is P1 we will put a key K, it will encrypt and it will produce a ciphertext C1. For P2 the same key we will use and it will encrypt and produce a ciphertext C2 and so on up to the, if we are entering the block Pn, then we will input a key K and it will produce a ciphertext, that is the Cn. In the case of the decryption, once we will encrypt all the data and we will move for the decryption, then with the same key C1, for the C1 we will use the same key and it will decrypt and will produce the P1 block. For C2 it will produce the P2 and up to Cn, for the same key of the K it will produce the Pn block. So this is the flow chart for the ECP mode of operation. Now we are coming on the advantage of the ECP. The ECP method is ideal for a short amount of data, such as an encryption key. The most significant characteristics of ECP is that if the same bit block of plain text appear more than once in the message, it always produces the same ciphertext. Parallel encryption of block of bits is possible, thus it is a faster way of encryption. Simple way of block cipher. For lengthy messages, the ECP mode may not be secure because if the message is highly structured, it may be possible for cryptanalysts to exploit these regularities. Prone to cryptanalysis since there is a direct relationship between the plain text and ciphertext. So, cipher block chaining mode. First one was the EPC, second one is the cipher block chaining mode, that is also called the CPC. The plain text is divided into fixed size block such as block 1, block 2, block 3 up to so on. An initialization vector, that is also called the IV. Initialization vector, that is also called the IV, is generated serving as the initial input for the encryption process. For each plain text block, the XOR operation. So what we are taking? We are taking the initialization vector that is serving as the initial input for the encryption process, and for each plain text block, the XOR operation is performed between the plain text block and the previous cipher text block or the initialization vector. The result of the XOR operation is then encrypted using the encryption algorithm E with the same key K with the same key. What is the encryption algorithm E? With the same key K, producing the ciphertext block. The ciphertext block becomes the input for the XOR operation. The ciphertext block becomes the input for the XOR operation in the next iteration. I will explain further. I will explain through the flow chart. So, what the output you will get in the previous process, it will become the output for the next iteration. That is the important thing. This process is repeated for each block of the plain text, resulting in a series of ciphertext blocks. During this, that is the part of the encryption. Now we are coming on the decryption. During decryption, the ciphertext blocks are decrypted using the decryption algorithm D with the same key K. What is the key? K. K is the key which we will use for decrypt the data which has been already encrypted. The decrypted ciphertext block are then XORed with the previous ciphertext block or the IV. IV is the initialization vector to obtain the corresponding plain text block. The decryption process is performed for each ciphertext block, allowing for the reconstruction of the original plain text block. It is the block diagram. So, it is the plain text and the plain text is XORed with initial vector, and the key which is used after the XOR of P1 and IV, the output which we will get, it will be encrypted with key K, and after the encryption we will get the ciphertext, we will get the ciphertext C1. Okay, so this C1 will be the plain text as a IV. Initially we started for the IV. Now plain text P2. Plain text P2, like, see, it is the plain text P2. So the output of the C1 will be XORed with P2. With P2, the output which we will get, it will be encrypted. It will be encrypted with the same key K, and what will the output we will get? We will get the C2. And for the further, if there is the P3 plain text, then P3 will be XOR with C2, and the output, what the output which we will get? It will be encrypted with key K, and once it will be encrypted, then what the output we will get? C3, and so on. So up to the K, it will be encrypted and it will produce CN. Now, it was the process for encryption. It is the process for encryption. Now we are moving towards the decryption. What will the process of the decryption? So for the decryption, C1 is the ciphertext, okay, and it will be decrypted by the using key K. Now the output which we will get after the decryption, it will be XORed with initial vector IV, initialization vector IV, and we will get the plain text P1. Okay, now for the C2, for the ciphertext C2, what will happen? It will be decrypted with the key K. It will be decrypted with the key K. What the output we will get? It will be XORed with the C1. It will be XORed. Now it will be XORed with C1, and the output it will be XORed, and we will get the P2. And same for CN will be decrypted. CN will be decrypted with key K, and further it will be XOR with whom? The decrypt part plus with whom? Cn-1. It will be XOR, and the output, what the output we will get? We will get Pn. What the output we will get? We will get the output Pn. Okay, so it is the process. Next, advantage and limitation of the CPC. CPC work well for input greater than B bit. CPC is a good authentication mechanism, better resistive nature towards cryptanalysis than ECP. Parallel encryption is not possible, since in the ECP it was possible. Since every encryption required the previous cipher, that is the reason parallel processing cannot be happened in the case of the CPC. On the other hand, in the ECP, we may encrypt the block. There were the number of the block, they may be encrypted parallelly. Okay, and the similar way, the number of the block which has been encrypted, we may decrypt these number of the block parallelly in the case of the ECP. But in the case of the CPC, because we need the previous output for the XOR, we can't do the parallel process in the case of the CPC. So these are the self-assessment question. In ECP mode, how is the plain text divided for the encryption? What is the primary disadvantage of the ECP mode? In ECP mode, how are the blocks encrypted? In ECP mode, what happens if two plain text blocks are identical? Throughout the session, student will gain hands-on experience with implementing and analyzing various block cipher mode of operation through practical exercise and programming assignment. By the end of the course, student will have a solid understanding of the different block cipher mode and be able to make informed decision regarding their selection and use in the real-world cryptographic application. Terminal questions. Okay, these are the terminal questions. You may go through these questions and find out the solution. These are the reference book from where you can take the reference for more understanding and more getting more practical knowledge. Thank you. Thank you.